So, we start from where we stopped, right. So, we are looking at fluctuating heat gain in the last class that we had, fluctuating heat gain. So, we continue from there, right, continue from there. This is casual heat gain. Casual heat gain, you will have mean casual heat gain here, and this is at any instant. So, the difference gives you the fluctuating component of the casual heat gain, right, fluctuating component of the casual heat gain, all right. So, QCT, if there is a significant radiant component of the casual heat gain, for example, if it is coming from some sources, right, and goes to the wall part of it and then comes back, then there can be a time lag associated with that also. But we generally neglect this. We generally neglect this for our purpose. We generally neglect this, okay. And I think this we looked into yesterday. Last class we looked into. Yesterday we did look into that. Yesterday we looked into that. All right. And then we said that ventilation heat gain is the one that we are supposed to look into. Ventilation heat gain, where we, so this is what we looked into. CV, we are taking care of constant air change at the moment. We are not assuming CV as a function of time. We are not considering this. We are assuming CV is constant. That means we have fixed rate of air changes. So, in that case, if it is CV, so at any instant the amount of heat transfer due to ventilation should be CV into outside temperature minus inside temperature. Now, outside temperature has got two components, one is the mean, other is the fluctuating, and inside has got a mean and the fluctuating. Now, out of this CV into TO bar minus TI bar we have taken care of in case of steady heat gain, mean heat calculation. So, followed from this would be then the fluctuating part, how it is. Remaining unaccounted portion is this, QV dash. I think that is where we stopped yesterday. CV, this is the fluctuating component of outside temperature and fluctuating component of inside temperature. This we did not take care of in the last mean calculation. So, assuming uniform room temperature, fluctuating component temperature is the ratio of fluctuating heat gain through all the surfaces to admittance. So, this is what I think is the statement is fine, but let us explain what it is, let us understand what it is. As far as this is concerned, QVT, I can write it like CVTOT minus only the fluctuating part. This out of this I can separate this out. This is the fluctuating portion of temperature and corresponding ventilation heat gain. Let us see how we take care of this, in the overall scenario. So, fluctuating heat gain through surfaces and gain of air is equals to fluctuating heat input over mean. Okay, that we have defined already, but let me just state this. So, what we are saying is total fluctuating heat that will come in through all the surfaces. We said Q fluctuating Fs plus Q fluctuating C, etc., etc. There are all of those fluctuating heat component if we take into account. This fluctuating heat component we assume to enter into through the room surfaces. We assume that they enter through the room surfaces, and this must go in increasing the fluctuating component of temperature. Whatever comes in through the wall, all fluctuating heat gain, all of them are not through conduction. Some of them are through conduction, some due to ventilation, some due to direct radiation, some due to casual gain. So, all the heat transfer that is occurring, we assume that takes place through the envelope surfaces, internal surfaces, such that T swing of inside temperature I can find out provided I know Q in, because this was nothing but admittance. What was admittance? How did you define? admittance is the amount of heat that should come in for unit temperature swing in the inside temperature. So, if the inside temperature swing is T I and assuming room temperature is constant all over the place. So, swing is T I, this multiplied by Y must be equals to heat that is coming in. Here one more assumption we are doing, we are assuming that it is not only the conduction, all the heat it comes in from different through various mechanisms through different surfaces, all that contribute to the fluctuating temperature gain, fluctuating temperature gain. So, if that is the case, then T I A must be equals to the fluctuating component of the heat gain. All that I sum up, like if you remember, we had several component Q bar F S I wrote, that was directly solar gain falling into the opaque surface, plus Q C, that is through the conduction, different components that we wrote yesterday, Q swing G C through the glass through conduction, plus Q I think we wrote something like S, different components we wrote other day, some of them. So, all this I call as Q total at any point of time, whatever is the total input. Now, this we assume this Q, that is total that is coming in, and that will be T minus 5 hours earlier, because some of them will have time lag, appropriate time lag I will have to consider. For wall we know the time lag. How did you calculate out this Q? We found out based on decrement factor and decrement factor and its corresponding time lag. For conduction we found out decrement factor and its corresponding time lag. Then ventilation, of course, we were just we said that steady part we have taken care of, we are taking care of now the fluctuating component of it. What about the radiation part of it? Radiation, we said that it was A I swing into theta, A I swing into theta, and this I might be I might be T minus some phi depending upon, but this will have no phi here, because radiation, solar radiation directly comes in instantaneously. Similarly, we had U A, mu U A, if you recollect mu U A, T swing, T O swing, T minus phi. That is the conduction heat gain. Sum of all these will give me the conduction, fluctuating conduction heat gain. All this heat gain that is occurring, I sum them up, and that I call as, because corresponding T I will have to, corresponding phi j would be there, this would be for different surfaces. So, for all surfaces and for all modes of heat transfer, I sum up the heat that is coming in at any time minus the corresponding time lag. Some will come instantaneously, for example, direct radiation will enter instantaneously, right, but others conducted, the heat transfer, I mean that is occurring by conduction through the wall, will come with a time lag, it will come later. So, I must take that all that into account, and this is my current time, this is the amount of heat. So, that will be sum of sigma of all those components, and that must be equals to sigma AOI, that must be equals to, so this Q T phi, just let me write it first, all this sum Q bar T minus phi j corresponding phi j, as I said, must be equals to A into y sigma of this into j surfaces sigma A y, right, sigma A y into T I swing, because by definition Q divided by T A I, by definition Q by T I swing, Q swing, T I swing, I am calling it as y. So, if I multiply all by A, sum it up for all the surfaces. So, that is what the equation is. So, total heat that is coming in, we are assuming that will go in increasing the fluctuating component of heat temperature, fluctuating component of the temperature inside, room temperature is constant, and that is what I am trying to do. But one problem remains as far as ventilation is concerned. ventilation, part of it I have taken care of. The part I did not take care of is CV TO swing minus TI swing. This part I did not take care of, right, while calculating the mean. So, this component will also go into my, into my, I mean this component, this has to be taken into account, and that is what is happening when I in this equation actually. So, all fluctuating heat through surfaces of air is equal to fluctuating heat input over mean, all fluctuating heat input over mean. So, T I A I plus C V T I, that component remains. C V into T I did not take into account. So, C V into T I, and in this one C V into T O swing, that I will take care of, that is taken care of here. This part still remains, because if you remember we did not take care of T O swing minus T I swing. So, if I add this whole thing here, C V T O swing minus T I swing, T I is unknown here and is equals to, so it would be something like this, it would be something like this, erase all out, it will be T I T A Y sigma for all surfaces equals to Q total, that leaving ventilation part, Q total leaving ventilation part, T minus phi, appropriate as I said, and also for the admittance I have to take into account, plus C V T O I minus T I swing, because C V I did not take care of, this part I did not take care of. So, this part is the rest of the things except the C V, let us say. Then this T I will come on this side, because T I swing is unknown. So, this will be T I plus C V. If I write it like this part can cancel out. So, this total includes C V T O swing, this total must include C V swing, then say T O swing, then I can write expression on this in this manner. All that I am trying to say is sum up everything, all the heat input, fluctuating component of above the mean. For the ventilation part, you sum that up together with that heat flow, C V into T O swing, outside temperature swing, the amount of heat that will come, because just because of the swing of the outside temperature. And left hand side you will have A y plus C V, sigma A y plus C V, because C V T I swing has to be subtracted out, and that is the equation would be, and you can you can now find out T I swing from such an expression, you can find out. So, T I swing will be given as, everything is included in all this, all that we are assuming that whatever heat comes in, that comes through the surfaces, although they are not really conduction, admittance was related to conduction, but what we are assuming is whatever heat comes in, because what we are saying is for any heat input into the room, that will go in increasing the fluctuating component of the heat gain. So, this is an assumption, actually casual heat gain is taking place at different points in the room, but we are assuming as if it comes through the wall only, as if it is coming through the inside wall only, and air temperature inside the room is constant. Okay. So, that is again an approximation, that is an approximation. So, this is how we can calculate out the inside temperature of a room, and let us solve an example problem. Maybe mean temperature we have looked into last time, we looked into. Now, let us look into the problem, same room we continue to see with one external wall, etc., all remains same, TOA. Now, what we are saying is calculate the internal temperature at 6 p.m. at a given time, given that mean TOA is 27, that is outside, earlier also it was there, and TIA is 30, this is I have just said that TIA is 30, and the mean global irradiance exposed wall is 180, assume alpha of the solid wall is etc., these are all same, 2 air changes per hour, and to be same alternating heat gain factor for glass is 0.42 with small lag. So, all things remaining same. Now, I want to calculate our temperature at 6 p.m. right. So, some additional data I need, the outside temperature given these are the also the data must be available to me, this data must be also. So, admittance values for all the walls are given, and within bracket are given the corresponding time lags. right. So, TL is given here. The decrement values are given here and corresponding time lags are given here. For window there is no decrement, for window there will be no decrement factor, decrement. Ceiling is given, floor is given, internal walls are given, right. So, now I want to calculate out the inside temperature at peak temperature, at peak time I want to calculate out the temperature, right. Peak temperature I want to calculate out. This is the data given. With this data given I want to calculate out the peak temperature. Temperature data is given here. Time 8, radiation 10 am, 12 mm, 2 pm, 16 etc., and outside temperature values are given here, right. So, I am interested in calculating at 6 pm, that is 18 hours. So, that everything is given up to 18, beyond that is not given, right. So, whatever temperature was there at 18 hours, no, I am interested in 18 hours, there may be something more, 6 pm I want to calculate out. Radiation exposed wall, outside temperature I might need, after that there may not be any radiation actually. So, after 6 pm, so after 6 pm there may not be any radiation, but temperature may still be there. So, this was anyway there. Glass area we calculated it earlier as well. Then time at which outside radiation is relevant is how much is a, see if I am interested in finding out the temperature at 6 pm 18 hours, the radiation 4 hours earlier, because time lag for admittance is given as, if you look at this table, this is the radiation at 6 pm, but this will, if I look at through the wall which was exposed, external wall, it had 4 hour time lag, 4 hour time lag. That means, the radiation which came 4 hours earlier would now affect it, but temperature rise inside the room takes place because there is a time lag associated with the admittance also. So, when the heat, at some time the heat comes in and 4 hours later the inside temperature rise takes place, because admittance has got a time lag of 4 hours. So, the temperature at 18 minus 4 means it 14 minus another 4, because the temperature at 10 am or radiation at 10 am will actually be entering into the room at 2 pm, 10 plus 4, 2 pm, but that will cause a temperature rise at 6 pm. So, 8 hours I must take into account. Similarly, for all others, for window there is window glass, the admittance time lag is only 1 hour, and admittance value is admittance value is 5.6. It does not have any mu decrement because heat will come straight away. For ceiling 3 hours and so on. So, this time lag has to be taken into account, and I am calculating accordingly, as you can see I am calculating it accordingly, right. So, glass area 9, 18 hours minus at 10 am, then I should take the radiation, because 4 hours, because the room temperature at 6 pm will correspond to heat entry at 2 pm, and the heat that is entering at 2 pm actually is due to radiation coming still 4 hours earlier, which means at 10 am. So, all the time lag we have to take into account and then calculate out. So, swing, therefore, 180 was the mean, and at 10 am the radiation is 500. So, the swing of radiation is 320, swing in radiation, fluctuating component of the radiation is 320, right. And therefore, QFS is due to what? It is due to radiation falling onto opaque body, and that would be area multiplied by U divided by H naught. Remember, H naught was 9, last class we talked about. Then there is a decrement factor, right. This was area, there is a decrement factor, and there is a decrement factor, U value, decrement factor, H naught and alpha into I. So, let me write this is area, this is U, this is this area, this u, this is divided by, this is divided by H naught multiplied by mu multiplied by alpha into I swing, that is equals to 27. Area was 9 meters square, that is what we have seen. Solid area is 9 meters square. Time is 10 am. Corresponding to this, we have calculated the fluctuating component of radiation, that is 320, that is at 320, and this is alpha value. Last class, last time when we solved for the mean, we use the same value. This is decrement factor mu. So, mu u a, right, that is the heat coming in, that is the heat coming in. Mu u a will be mu u a alpha I by H naught I swing, that will be the heat coming in due to radiation falling into the opaque surface. So, that comes out to be 27 watt per meters, watt not per watt per 27 watt, this is 27 watt. So, that is how we calculate out. And QFC due to conduction, now I will take same 10 am time temperature, and that is 34, mean outside is 27. So, fluctuating component of the outside temperature is 34 minus 27, 34 minus 27, at 10 am it is 34, and this is mu, this is u, and this is the area. So, here mu u a into delta T, mu u a into delta T, that is 13. So, this is the conduction gain through the opaque body, sum total of these two. Then follow it up with Q direct solar radiation. Direct solar radiation, there is no time lag. So, at 6 p.m. this is 6 minus 4, I mean 2 p.m. this is 360, because admittance 4 hours I will have to take into account, but I do not have to take into account of the glass direct radiation, because it will have negligible time lag. So, 360 minus 180, 0.42 is the solar gain factor 9, and this is what it is. So, A I, this is theta, and I fluctuating is equals to 684. So, this is through the QS stands for direct solar gain through glasses. Then follow it up with conduction through glass. This is conduction through glass, and when I have conduction through glass, it had 1 hour of time lag. So, 5 hours earlier, I calculate out, because this was 2 hourly temperatures were given. So, I take the average, 5 hours earlier is 35.5 minus 27, that is the fluctuating temperature, right, and this is the mu, this is the u, and this is a. So, a u mu and tau swing 64, that is what I find out. And then we are assuming there is no casual heat gain, Cv is 60, that we calculated outside. Qb is equals to 60 minus 35 minus 27, right. Now, this is what 27 is the outside mean, 35 is the temperature at that point of time at 6 p.m. 6 minus 4, that is at 2 p.m. because 4 hours time lag will always be there because of admittance. So, 35 minus 480, this is to be added. So, you sum all of them and you get 1268, sum all of them and you get 1268, right. 480, 60 plus 684 plus 27 plus 13, if you sum all of them up sequentially as we have done, just look at them, all that we had, we summed up all of them, 64, 684, 13, 27. So, this makes it 40, this is 104 plus 684, 784 plus 104 will make it 888, right, and then followed by this is 888 followed by 60 plus 480. So, 888, 60, 480 would be 8, whatever it is, maybe I might, if I have made a mistake, there is a possibility, but it comes out to be 1268 in that manner. So, that is the total fluctuating heat gain. Now, this must be equals to sigma Ay plus Cv into Ti swing, because half of the Cv part we have taken, this is the outside part, inside part remains. So, therefore, I calculate out y for each one of the walls are given, area corresponding ones are given, I find out ay and then sum it up for all. But here remember, even internal wall you got to consider, all walls you got to consider, unlike the while heat coming in comes through a one wall, but we are assuming that in a kind of a gross manner all the heat, casual heat gain or ventilation heat gain, this is all as if the wall receives them, that comes in, but get distributed through the internal walls. That is an assumption we are making, and that enters into the room 4 hours later, because 4 hours is the time lag, and causes a fluctuation in temperature. So, ay for all walls I must consider, internal walls inclusive, because we assume, this is the assumption we are making, that it will get distributed through all the walls. In fact, what will happen is, supposing there is a ventilation heat gain, air exchange is occurring, this would result in heating up all the walls, internal walls, right. It will not selectively may come through one of the windows, but finally the room temperature and air temperature, they surface temperature, internal surface temperature, they would be, there is a like it cannot be that one wall is very warm compared to other walls, they will get distributed in some manner, because we are assuming room temperature, air temperature inside the room is constant. So, what we do is we calculate for all the walls here ay. So, while calculating the heat gain, you take specific ones, while calculating the sum of the admittances multiplied by area, it is for all the walls, So, that is what we do, and then this sum is 466.8. So, what is my Ti swing? This divided by this plus Cv. So, this plus Cv, let us see what is it, this plus Cv 1268. So, this is a already I have taken care of this, 1268 divided by this, so 2.7. Now, at 6 p.m. what is the temperature then? Mean plus 2.7, mean plus 2.7, mean plus 2.7. So, T at 18 will be 30 plus 32.7 degrees centigrade. So, at every time therefore, you can find out in this manner, you can find out to all 24 hours what is the temperature inside. So, all that you have to do is summing up, calculate the heat gain, taking the appropriate time lag, and you calculate all casual heat gain, direct solar gain, all ventilation heat gain, all, and we make an assumption that as if it is all entering through the all internal walls and causing a change in temperature of the inside. Therefore, we take admittance of all the walls, Cv part of the Cv or ventilation heat gain, mean ventilation heat gain we took care of, but part of it we did not take care of. So, Cv into To swing, that is added into the heat input, and while calculating Ti swing, Cv comes into picture here, and that is how we calculate out, and this you can repeat for all the time of the day. I think we'll answer some of your questions, then go to the next one, right.